So here's a short run through of the Modtran webpage. I've logged in or gone to the URL that's in the assignment, and I've refreshed the page, so I've got default values for a tropical atmosphere with current values of CO2, methane, tropospheric ozone, water vapor, etc. I want to turn these off to start, so we'll just set everything to 0. And after we adjust, so it takes a little while to recompute, we should see, here we go, a black body. So we've got no atmosphere, and the surface is at 299.7 Kelvin to keep it distinct from the 300 Kelvin black body. And we're at an elevation of 70 kilometers looking down, no clouds or rain. Now so we can now see what happens when we put a little bit of CO2 in. So at 70 kilometers, we're now looking at an absorption line at 15 microns and then this band. If we want to see what temperature these things are coming from, in order to eliminate a little bit of confusion, let's go down to the top of the atmosphere at 17 kilometers. So we're just looking at from here on down, and here you can see we're seeing temperatures of 220, and if we let's go to 17 kilometers and put in 10 ppm. So here we can see that we're looking at temperatures that are actually closer to 200 degrees, which is what we'd expect in the absorption emission, strong absorption emission right from here. Now what happens if we increase the width by changing the CO2 concentration to current levels and then to very high levels? So now this band has become black. All the photons are coming from right here. And so now let's pull back a little bit. So I'll move to 25. And we're beginning to see the absorption line bring photons with slightly different temperatures. If I go up to 40, so now we've got a absorbing and emitting line that actually is at a higher temperature than the wings. So all three of these points here, here, and here are black, but they take a different amount of CO2 to actually make them black. This requires very little CO2 in your path before it becomes black, and so these are photons that are the closest to the instrument at 40 kilometers. So this is a temperature of about 245, and if we look at 40 kilometers, so these photons are coming from just a few kilometers below 40. Maybe 245 is right here, so maybe about 3 kilometers down. These photons are coming from 220 degrees, and that then would be lower in the atmosphere. Temperature of 220 is at 24 kilometers. Why are they being emitted from a lower part of the atmosphere? Well, most of the CO2 is actually down there, and so in these wings you need more CO2 to become black, and so between 20 kilometers and the instrument at 40, there just isn't enough CO2 to absorb and re-emit. So we're seeing into the atmosphere at a different depth at different wavelengths. And in a separate screencast, I'll go ahead and take a look at ozone absorption, and we can see what the spikes in the wings of the ozone absorption line look like.